All right, let's get into this, because the history of video games is filled with some wild stories. But this one might just take the cake. It's a story that doesn't start in some Silicon Valley garage, but right in the heart of the Cold War. So I want you to picture it. It's the early 1950s. The world is tense. And at MIT, some of the world's best engineers are building one of the most powerful computers on the planet for one single, terrifyingly serious job: national defense. Well, as it turns out, everything. That exact same military machine, the one built to stop a potential World War III, accidentally became the birthplace of the very first graphical computer game and the origin of video game physics as we know it. So how on earth did that happen? Well, to get it, you first need to meet the machine at the center of this whole story. Say hello to Whirlwind. And this thing was an absolute beast. We're talking rooms full of vacuum tubes, miles of wires, the whole shebang. Its main job, under the direction of an MIT grad named Jay Forrester, was to power this massive early warning system against surprise air attacks. And this just perfectly captures the crazy contrast here. I mean, on one hand, Whirlwind's official purpose was deadly serious, crunching radar data to track enemy planes on its huge screen. But on the other hand, it had this secret, totally unintended talent that would, no joke, change entertainment forever. So, how does a military computer start playing games? It all kicks off with a simple little programming exercise and a revolutionary new idea. You know, Charles Adams wasn't trying to invent the next big thing. He was a part-time student working on the Whirlwind project, and he was just trying to create a little demo program to help other students figure out how to even code for this ridiculously complex machine. And it was exactly what it sounds like, just a single dot of light on a screen, programmed to bounce around, well, pretty much like a real ball would, following the laws of physics. So simple, so elegant, and way more important than anyone could have guessed. See, this little program was showing off something absolutely game-changing: real-time computing. Bouncing ball was the first time anyone had actually seen it in action. Before this, you'd give a computer a problem and, maybe hours later, it spit out an answer. Whirlwind could react instantly, and this little bouncing dot was the proof. This was such a huge deal. It was way more than just a cool visual. It was a massive leap. That dot reacting immediately to what you were telling it to do, it created this whole new relationship between a person and a machine. For the very first time, it felt like you were having a conversation. But the story doesn't stop there. This little tech demo was about to get a surprising second life right inside the classroom. Charles Adams pretty quickly realized, hey, this thing is actually an amazing teaching tool. So for a summer course he was helping with, he gave the bouncing ball a goal and objective, turning his simple demo into a real interactive challenge. So here's how it worked. First, the students had to actually do the math on paper. They had to solve a differential equation to figure out the ball's trajectory. Then they'd go over to the massive Whirlwind console, use these physical knobs to plug in their numbers, and try to guide that little bouncing dot on the screen into a hole at the bottom. And you gotta remember who was playing this. These weren't your average Joes. They were brilliant engineering and science students at MIT. So you'd think solving a pretty basic physics problem would be a piece of cake for them, right? Well, you'd be wrong. The failure rate was shockingly high. It turns out that even these brainiacs had a really hard time translating their perfect paper calculations into successful real-time control. Interacting with a machine this way was a totally new skill nobody had ever practiced before. And boom, just like that, another first for the history books. Bouncing Ball wasn't just the first real-time graphics demo, it was also the very first video game ever to be used as part of a university course. So why does this 70-year-old story about a bouncing dot on a military computer still matter today? Well, because it left behind two incredibly powerful legacies that pretty much shape our entire digital world. It left behind two huge ideas. First, it taught everyone a crucial lesson. Showing is always more powerful than just telling. A simple bouncing dot captured people's imagination in a way that pages of raw equations never, ever could. And second, this was it. This was the moment that physics simulation, the art of making a digital world behave like the real one, became a cornerstone of game design. At the end of the day, these programmers and scientists weren't just goofing around. They were driven by this much deeper question. Could they take the fundamental rules of our physical universe, things like gravity, momentum, acceleration, and actually recreate them inside of a machine? And you can draw a perfectly straight line from that one single bouncing dot in 1952 all the way to the incredibly realistic games we play today. The exact same idea, simulating physics, evolved from moving one pixel to building entire worlds where everything from the way a character's clothes fold to a massive explosion feels real. It all started right there.
So it really leaves you with a fascinating question to chew on. A simple programming exercise designed to teach a few students on a military computer accidentally laid the foundation for a multi-billion-dollar entertainment industry. It just makes you wonder, what simple demos and classroom projects out there today might just be the accidental revolutions of tomorrow?